Oh, yo, what's up, everybody? Welcome back. Today we are working on our image editor, and today's topic is trying to do some form of cut and paste. So, this is my image editor. It's not much right now. We can, open it. We can say, hey, I want to edit a couple images. Right, let's just open a couple images. We searched image on the internet and we got a couple samples. And so like these two ones on the top are the samples, this guy and this guy. And then we have implemented a shader runner that basically like, takes in an input image, executes some form of shader on that thing, and turns it into some sort of output image. And then we have like this like idea of like a composition of images where we can like kind of position these guys relative to each other. Now today I want to implement some form of copy paste or cut and paste. So the thought here, the overall vision for the editor is that every action that you perform through the UI is implemented through a few simple primitives, right? We have objects, images, whatever you want to call them, like rectangles of things that we can show, right? That's kind of like all of these things. You can like construct images from like multiple sources, right? So one source is running a GPU shader on these things that you can like write by hand. Eventually, we don't really have like UI for that right now, but theoretically. And then like maybe another input could be like a path that is generated. So maybe we can like click on like the cloud here, outline him, and say this is a path, and then the next action would be like turn that path into a mask. So like fill in everything that you got. Maybe we can kind of like draw it out. So like say we're trying to like color this. We're trying to like mask off this cloud, right? So we would do something where we like draw a set of points along this thing. Boom, 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 something like that, right? And we can like kind of like fill this thing in and generate a mask from that, right? Right. Then what we can do is we can use this like colored in thing as the input to a shader that says, okay, if we want to cut and paste this thing, well, we take the mask and we multiply it by the source image. That's a new image. And we take the inverse of the mask and we multiply that by the image. That's another image, right? And then the idea here is that we'll be able to go back in time, kind of like drag handles of this path that we generated around, and everything downstream will just like update itself for free, right? So if we have any composition that depends on the masked version of this thing, then that composition will just like update with with whatever we changed, right? So the idea here is like every action is editable, and every action goes through primitives of like path, image, maybe like transformation in a composition, and a shader. And then the idea is that like maybe we can open the shader and make whatever adjustments we want to make. If we want to do like color shift like we've done here, this is just like a custom shader that swaps some red and green channel, right? Or we want to do like brightness matching to another image, or like lighting matching. We can maybe like implement a gradient as a shader that applies a different amount of brightness change based off of the UV coordinates that are passed in and stuff like that, right? That's the vision. So plan of action for today is to do some sort of like path generation, try to generate the mask, try to implement some sort of path editing, and then probably after that, we might want to maybe we'll do some sort of like apply mask to something. Once we have that, then I think that probably as we start trying to like edit paths, probably changing the size of the UI is going to be relevant. Like we might want to like zoom in on something, right? And so we want to zoom in, then we'll have to implement something there. And then if we get through all of that, maybe we want to start doing like shader editing, right? So that we can like tweak what is done with these like masks. But generally, like cut and paste supports should be ready before that. So let's just jump in and do some path generation. So my thought here is that we kind of have like objects, right? These are our 4 objects. We put these into a composition at the end. If we're working in like GIMP, it's pretty common to, I think, work in like this view. I think that maybe later we will want to implement something where we can like draw a path in this like composited image. But I think maybe initially it makes sense for each path to be owned by an object. I think that's kind of like, or owned by an image. I think that's the way it makes like most sense. Because otherwise we need some UI to like say I want to edit this path. And what do we show behind that when we're editing the path? Like say I like outline this tree, right? I outline this tree. And then I jump over here. That outline isn't really like relevant anymore. It's kind of only relevant on this. So my guess here is that it makes sense for a path to be owned by one of the images, but maybe later I will like disagree with that. It also makes it simple to like, if we wanted to draw a path on like a composition, we might be able to do something that's like, we convert this composition into a single image and then draw the thing on top and then like work it downstream. That would kind of like, everything would just kind of come for free if we like basically rendered this to a texture first. I don't know. I have to think about it a little bit. But for now, I think the idea of parenting a path to an object just makes the most sense. So I think we start there, where maybe like when we're in the object view, we might have like the ability to like right click and bring up a context menu that's like create path from this, or maybe it goes in like the object properties. That seems kind of reasonable. So we have like this thing where we say like this object properties has like a source. It comes from image.png. We could like put some UI in here that's just like create path, maybe down here or something. Yeah, let's do that. So where is our UI stuff? Render object properties. So maybe in here we'll say, if we are in a file system view, we can add create path button. And then maybe we also do that in like the shader view, right? We can kind of do this here or here. It's just like in the composition view, it might not make sense, but in these it probably does, both of these. So let's do that. So can we just say like CIG add button, IG button, yeah, nice. And his label is going to be create path, right? And if this thing is clicked, what was the second argument here? It was size, so null size here. We'll kind of let him figure it out. If this thing is clicked, then we're gonna like say that we want to output, we want to like perform some action. So probably this guy is going to return some sort of like property action. And for now, it's just like create path. Okay. Property action. And then probably we want like a create path button, I guess, who's just gonna return a property action. And maybe we'll say like none as the default. Maybe this will be nullable. Maybe that's a little bit nicer. None is fine. That's fine. So here we'll say if maybe we just return the pool here. That kind of seems nicer. So this goes here. This says return, just return this thing. I changed mine. I want this to have the mapping to property action. So maybe we'll do this. Nullable, property action, here, here, and here. That feels kind of nice because then we can just say if create path button, we say ret is equal to action. And then we could do like put a ret up here. Like this. And then we can kind of do this same thing here. Boom. Okay. I don't know. And then here we just return ret. And then if this thing happens, we have to like do something with that action, right? So we're just gonna say like switch on the action, and if the action is create path, we call some sort of like app create path or something, right? Seems reasonable. Seems reasonable. Which means that in here we're gonna have some sort of function that's like create path, okay? And we're gonna look at like the currently selected object. So we're gonna be like self objects get the currently selected object, and if I guess we don't need this. We'll just say that the like parent is this. Maybe we'll just for now log something. Create path. And let's just kind of start by seeing if that like does and looks at all reasonable. He's mad because at main 200 greetings. Greetings. Hello, 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 hello. What's up, you guys? Okay, so I guess everybody else who returns has returned null. That makes sense. And create path can fail, but I mean, it can't yet, so we'll just kind of pretend they can't. That's true too. We need to do, if this, we get property option, create path, else null. There we go. Okay. So now when we're in this, there's like a create path button. Cool. And that works in both here and here. Okay. GFW, so you're not a fan of Vulkan. I mean, my understanding of Vulkan is that it's like you trade more effort for more control. And I don't think that I've ever felt that I needed more control than what OpenGL gives me because I'm shit. Maybe if I was really deep in the graphics knowledge, then I would care a little more. But for now, I've never hit a limit of OpenGL. I've never come even close. So I'm going to use the easier API for now. Although your comment on GLFW, I might ditch GLFW eventually. I think it would be fun to claim that this app has 0 dependencies, in which case I need to write a windowing library, which I think is not that hard. I guess OpenGL will always be a dependency, so maybe I can never make that claim. Okay. So object here needs to have some sort of implementation for a path. Okay. This seems reasonable. So what is a path object? He's going to be like, he's going to be like a series of points, right? So he's going to be like, probably like an array list of vec2, probably unmanaged. And he's going to be default initialized with nothing. Okay. First create the universe. Yeah, he's still in OpenGL. Yeah. Good point. Yeah. We classic. Okay. So this thing is going to have some sort of like dinit function probably, right? Who's going to take in himself, and he's going to have to like clear out. He's going to have to clear out his points. Okay. And then he's also going to have some sort of like create function. I guess creation is just free. There's nothing we have to do for that. I guess we might. Yeah, we'll have like a load function probably that's going to take in the saved path or something. But we can handle that later. We can handle that later. So for now, let's say that on save, if we see a path object, we just write unreachable because it's not implemented yet. And also on load, we'll do the same shit. Okay. Then I think render is the other place where this stuff comes into play, where we have to figure out how to render a path. Here, where is this called? Here we go. So here we have like, if a path is rendered, I guess we'll write unreachable as well. Let's just try to get compiling and then we'll kind of handle the crashes in a minute. He's actually mad that this thing doesn't exist. Oh, because our save object doesn't have a path. Sure, that's true. That's true, we haven't made that yet. Okay, we're missing a switch at 47. What's going on here? So, I guess dinit for this is quite simple. It's just this. So we can kind of continue on. Switch must handle all possibilities at main 204. Okay. So this is on render. So on render object properties, we might want to show some things in here, but for now we'll just write path. I think we'll probably want to show like parent object, as well as like, maybe that's it. I'm not really sure. Okay. So presumably we try to run this thing. We call create path. Oh, he doesn't actually make the path yet, so obviously that won't do anything. So here is where we're looking. We have self, and we just want to go like self objects. And what are we going to do? Append some sort of like object. So I guess he needs like a name. So I guess we'll just say like I guess we'll just make the name new path. That's pretty reasonable. So we have like path object. The default path has like 0 elements in it. Okay. And so I guess we just make one of those things. Name is going to be equal to new path. And I think that this expects the name to be like owned. Yes, I think we have to do like Alec dupe here. We need to use our allocator, and then we need the data is equal to some sort of like path, right? So something like this. Let's see how to do that. We need to return an error here, which means the caller of this thing needs to propagate that error. I guess we could argue that maybe he shouldn't crash the application in this case, but you know, fuck you. I can do what I want. Why is he still mad? Did I not save here? I did not. Error needs ignored at 125 because I didn't write try here. That's a good point. Okay, so if I go into this thing and I type create path and I click on this, we now crash because on render we don't know what to do. So I'm noticing that we forgot at a critical point piece here, which is that he needs the parent object. Like who am I relative to? And I guess this is kind of like display object more. Like parent is kind of strong. This is more like which object do we want to link to this path only for the purpose of rendering. It doesn't really have to exist other than that because everything is in like kind of like normalized coordinate space. So I don't think it really matters. So here we just have like display object is equal self selected object. And then on render, all we have to do is basically just render the child thing, right? So I think we just call render object with transform, like the same thing that we're already in, and we just pass on the current transform. And we use just like the display object here. Seems reasonable. And then, oops, this has to go inside. Like this. And it is true that this should not be an object, this should be an object ID, so this should be an object ID. What's the fucking problem then? Probably because when I try to render, we probably are supposed to pass on this. Boom. Boom, boom, boom. Fine. He wants a dereference of this thing, I guess. Fine. Okay. And so now I go in here, I say create path, and this is tied to this. And if I say create path here, this is tied to this. Very nice. And we're in like a path view. Okay. So now we probably also need to like render the path in some way. So maybe our default path for now will like have some points in it actually. Maybe that makes sense. So I think that our coordinate system is like -1 to 1 on both axes right now, which is probably wrong. At some point we're gonna have to account for like aspect ratio. But for now we can just kind of do that as is. So path. So when we create our path, let's like shove some points in here, I guess. And then those points are gonna have to be like uploaded to the GPU for rendering. So maybe we start looking at this path object and we make like a proper init function. So he's gonna have like initial points. Probably something like this. he's probably going to have like an allocator that's passed in. And he's going to look at the display object here as well. Okay. So we're going to do something like this, right? And then we're going to have to make our... this goes like this. And we're going to have to like copy the initial points in. So var points is equal to this thing. But with initialized with some capacity of initial points. Like this. Did I spell this wrong? Initial. There we go. Or is there like an init from slice even? Init buffer. That feels pretty good. That's a little nicer. And then we're probably gonna have to like create some sort of like GPU buffer for this thing, right? So we're probably gonna have like a array object. Points array object. Which is gonna be a GL uint probably. And points buffer is probably also going to be one of these. And then on dinit, we are probably going to have to free those things. So it's like GL delete buffers of self points buffer. And GL delete arrays of self dot points array object. Which I think needs us to specify that we're passing in one of these things. Like this. Okay. And that means we're gonna have to like create these things. So I think we do that down here somewhere. Create buffers, bind buffers, create vertex attribute data. Okay. So we have to bind some buffer data here, which I guess is just gonna be like probably like points, right? Points dot len times 4 points pointer. And I believe that after you put this data in there, it's like immediately, we don't have to worry about the fact that like the array could like resize itself and its memory could move. I'm pretty sure that this just kind of like buffers the stuff it's internally in OpenGL land. So I don't think we need to worry about like this going out of scope or anything. Then we create a vertex array from this thing. We're gonna have to make like a points shader, right? So I guess like the existing program that we run is actually more like a object render program, right? Because maybe object render is wrong. Maybe more like a plane render program, right? So he renders a plane with an image on him is kind of the existing thing, and the vertex shader test is gonna be like plane vertex shader, I guess. And this can be plane fragment shader like this. Okay. So here, our plane vertex shader, we can now start up like a points vertex shader, path vertex shader. Okay, that's looking pretty good. And what's he gonna take in? He's not gonna have like UV coordinates. We might end up passing in like the point, the coordinate along the path or something, like how far into the path we are. But for now, I think we'll just take in the position and maybe the transform, right? We might need to apply some form of transform to this thing if we're displaying it on top of something in a composition, but maybe we kind of ignore that for now. Maybe literally right now we just do this. Seems pretty reasonable. And maybe we have like a path fragment shader as well. And for now, can we just be like, like, let's just, you know, get crazy and make it white? I don't know. Maybe. Maybe. And I guess our program concept of plane render program is actually going to still be pretty relevant. We're going to want like a path render program who's going to have all the same pieces of data. He's just going to use a different vertex shader and fragment shader. But in reality, yeah, I guess this stuff is different. Yeah. So here we're gonna have our, what do we call? Did we call it vpos here still? We did. Okay, so we're gonna look for vpos. We don't give a shit about this stuff right now. This stuff is all the same, except the vertex buffer is coming from somewhere else. So I guess maybe we pass in the VBO here because for the plane render program, every single plane is like the same 4 points. This is no longer the case here. So maybe we pass in the vertex buffer ourselves. Okay. But this stuff still happens. We still need to set the parameters of the inputs to the program. So the only difference here is that the things are packed as like just points. We don't have to worry about like packing in color as well. And we have no transform location. We just have the vertex buffer and vertex array. Okay, dinit is going to look similar. We delete all of those things, but render is going to look a little different. We don't have a texture. We don't have a transform. We're like literally just like render this shit. And what does rendering look like? We bind the program, we bind the array. We don't bother with any of this stuff. And instead of drawing a triangle strip, we draw like GL lines of the number of things in here. So num points, maybe we'll say. Okay. Num points, boom. And here we'll just be like num points is equal to num points. And here we'll render from 0 to self num points, I guess. Here we need to change anything that says plane render to path render program. And it's possible that some of this might get like move out of here. I'm not really sure. In fact, yeah, I'm not really convinced that this stuff should live in like its own thing. The reason we had like a program before is because there's like multiple people that are rendering these plane objects, right? Depending on if we're like going through a shader or through a composition, blah, blah, blah. Kind of for the path object, it kind of makes sense for this stuff just like all kind of live raw in here. For now, we don't need like another layer of indirection. So can we like try to like merge this stuff together? So our init function is gonna look like this, and he's just gonna do a lot of the stuff that we did down here. So yeah, that does feel kind of better. So we do this, our vertex array stuff we're gonna take from the other one. Okay. Okay, this stuff comes from here. Vertex array stuff comes from here. And then the rest of this disappears. Okay. Path render program doesn't do this. This is just path object now. And we need to merge our dinit functions. So, yeah, sure. And really, I guess all path programs will use kind of like the same program. I guess they're all path objects are rendered with the same program, so we don't actually need to store the program in here. In reality. So how do we do that? Maybe on init? we pass in the path render program so that we can extract information from it. Or even like the locations of the like inputs to this thing are kind of fixed as well. So maybe we just pass in the vpause location. Duronic, thanks for the prime. Much appreciated. Hello guys, hello. Yeah, maybe this makes sense. So then we don't store the program here. We do store our buffer. We do store the array, and we do store num points kind of comes for free now. So all of this stuff is going to go somewhere else. Probably in like app. Right? We're going to be like, this is the plain program, and this is the points program. Path vertex shader, path fragment shader, sorry, the path program. Okay, so plain program here, path program here, and this is the sure, yeah. Oh, which brings back the concept of the render object. I think I understand now. So we'll bring it back. Path render program. He stores literally just the program, not the buffer. He's initialized with kind of hard-coded path vertex shader, path fragment shader. He pulls out the vpause, does no buffer binding. Yeah, here we go. This is starting to feel like it makes sense. So this is a CGL or GL uint. This gets the vpause location. Let's go vpause location. Nice. And then on render, this is going to do the actual work. So he's going to render with a array object. Yes. Okay. So he's going to do as well as the num points like this. And he's going to be like GL lines from 0 to int cast num points. And he's also going to draw points on top. And that feels pretty good. Okay. So that means up here we can do path render program in it. And then we defer a path program dealing like this. Hell yes. Okay, so then we have plain program, which we should probably rename, and then we'll put path program here. Fix me, rename program to plain program or something. We'll kind of cover that later. Okay. So what happens now? On render, wherever the fuck our like main render thing is, we render the background thing, and then we call like self plain path program render with this object. So you have p vertex array and p points buffer points.len items len. These are the parameters that we're rendering with. And now all we have to do is like populate some points on this thing on init. Okay, seems reasonable so far. Seems reasonable. Where's our path object here? Probably init buffer is supposed to take in the allocator here. We probably have to handle some sort of failure of everything below. We generate our buffer, we bind the stuff in. All right, That's like a maybe. That's a maybe. Fuck. Okay, vpos location is mad it in plain render program. 315. Oh, oops. Path render program on all of these guys. Okay, so then he's mad because this should be a GL int, not a GLU int. Okay. Now he's mad about missing field points buffer at 136. Yeah, here we're supposed to do path. Data is equal to. What is it called? Path object? Yeah, it is. Okay, and then this thing needs some parameters. So initial points, we have to set. Display object is self selected object. And the vpos location is from self path program vpos location. Nice. Excuse my newbiness, what OS are you using? We're using Linux, Nix OS to be specific, but I don't think it really matters. It's not really that relevant here. Yeah. Okay, so we need some like initial positions. So this is gonna be like a bunch of vec2s. And we're gonna be like, I don't know, let's just start some at like -0.5, -0.5, 0.5, 0.5, right? Let's try to go from like bottom left to top right or something. Just so that we have something to look at to see if the rendering is working. We're close. He's mad at... Oh, interesting. He wants a bunch of vec2s here. Which I'm not sure if pack correctly for upload. We might have a problem there, but we'll just try first to see what happens. gl.points is should be gl.gl points. Okay, and then points deinit is mad at 704 because this thing needs to be a mutable for that to work. Points array object is now vertex array here. Do we have vertex buffer? We don't need both of those things. And probably here he's pissed off because like this is supposed to be like this. Oopsies. S array buffer. Okay. Close. No field name program at 707. True, because this isn't holding the program anymore. He's holding the vertex array and the vertex buffer. That's kind of it. And then this render here can't use the program. This doesn't even exist. Fuck this render function. Path object init at 139 is pissed off for missing allocator. Okay, and then expected cuint found cint at 139. Yeah, so I guess that's in here. This should be a glint. Okay, now he's mad at error checking at 139. We have to write try here. Expected 1 argument found 2. Oh, this is not what I want. Yeah, this is not what I want at all. Okay, so we want init capacity of initial points len, and then we need to push the points. It's points append slice of initial points. Fine. Fine. And then I guess this probably has to take in an allocator and try. Points.len is mad at 687. So what's he pissed about here? True. True. 687 is mad again at an int cast here probably. Boom, boom. And then points.pointer, maybe points items pointer. Fine. Fine. If you're going to be like that, expected object data found path object. So I think it's here. We have to do like path is equal to this or something. Nice. There we go. Okay, we compile. Okay, let's get moving. So we click on this thing, we hit create path, we get a new path here, and we do see a line here. I'm kind of surprised at where it starts and ends. I kind of would have expected it to go farther to the top right. Can we control the width of this thing? Can we do like GL line width 4? Okay, yeah, so it's definitely not going where I thought. This negative 0.5.5 feels right. Why is it not going to 0, 0? Hold on. Is num points here supposed to be... No, yeah, it's supposed to be 2 vector 2s. Okay. Let's see just kind of how broken this thing is. So we do like 1.0, 1.0. What happens there? It seems like it's going to 0, 0, kind of somewhere unconditionally. It could be because the packing of the vec2 is wrong. This did something. Is it because the stride is wrong? Okay, so what do we type here? We said that the stride is... We have 2 inputs of floats, forward by 2. Okay. So let's just double check here again that if we do this, it's no good. Yeah, and then if we just throw in one more, is it like... Let's see. Still no. What the fuck? How many of these do I need before it starts working? Now it's fine? Like, what the fuck? What the fuck? Okay, let's, I guess... Points items dot len times 4 is a reasonable size here? No, times 2. Because each item is a vec2. So times 8? Ah, so we weren't uploading the whole buffer. So that's why we have to double up the length. So this should be fine now, I think. Create path, new path. Yeah, that looks pretty good. That looks like it's going 0.5, 0.5, negative 0.5, 0.5, because that's halfway to each corner. Looking pretty good. I'm not gonna lie, I kind of want the width to be larger. And then can we do like GL point size or something like this? Does that do what I want? Create path, new path. We almost want the points to be like bigger, like fucking mega big. Mega big points. Boom, boom. Yeah, okay. That's what I was imagining. Right, so now we have to make it so that we can like drag these things around, and then probably we also want to be able to like add points. Feels so high level after taking a month to make a trial on Vulkan. Yeah, that's kind of how I feel too. I haven't done Vulkan, but OpenGL does feel kind of high level now. Okay, so probably there's a fix to be done here where the color of this thing might actually want to sample from the underlying image and invert the color or something, right? We might want to do something like that so that like a white thing isn't always white, or maybe we set the color in the object properties. That's like another option. But for now, let's just try to figure out how to like drag these things around. How am I supposed to like update GPU buffer data? Am I just supposed to like modify it and then call GL sub buffer data? Is that what I'm supposed to do? There's like GL buffer data and GL buffer sub data, and I don't really know what the difference is between them and when I'm supposed to use one versus the other. Redefine some or all the data store for the specified buffers. Data starting at byte offset and extending for size bytes is copied to the data. Must define a range lying entirely within the buffer object's data store. So I guess if we are like modifying existing data, if we're modifying like one point, maybe this makes sense because we can say only change this one part of the buffer. And then maybe if we're like changing the size of this thing, it makes sense to use GL buffer data. I'm not really sure. When to use GL buffer sub data versus GL buffer data. Surely somebody's asked this before. See notes there, I spoke to that. When replacing the entire data store, consider using buffer sub data rather than completely reconfiguring. This avoids the cost of reallocating the data store. Consider using multiple for objects to avoid stalling running the pipeline. But here, I guess so that's only saying like it's not clear to me if I'm adding elements to here. It seems like this is invalid, right? Like I'm not crazy because it said that size needs to be within the existing object data. So yeah, I think that's like basically what I was thinking. I just wanted to make sure that like supplies data VBO, blah blah blah. Combination of malloc memcopy. Yeah, okay, sure. That lines up. So I guess somewhere we're gonna be like, let me change the positions of this thing. Okay, so we're gonna be like, the old position was like this thing. So we're gonna look at like probably the index. And we're gonna be like, here's its new position, right? Maybe we'll say how much we moved. That might kind of end up looking a little cleaner. We might even want to go like, so what's gonna happen here? I guess we have somewhere where we like have click drag support, for composition objects, right? So we say like on mouse down, find the closest composition object, and I guess now this behavior is gonna be different. If we're like looking at a, right, because we can't edit a path in a composition. We can only edit a path if we're already in a path. Or so I guess the view, the like current object kind of makes this behavior change. So maybe let's just start by trying to print out to the screen the closest point ID. Let's start there. So let's say that this is a find closest path, and here we'll call this our find closest path point. Okay. And we'll say that what we did before was like render any path. How do you keep motivated to code 10 hours straight? I just don't code 10 hours straight. That's the fix. I find that when I code, even if I'm motivated to code 10 hours straight in a day, doing that many days in a row burns me out. So my answer is I don't. I just, yeah, you can make a lot of progress in a few hours. Like it's very, very possible. I find that like at work, when I was working, like I could do the same amount of work in 2 hours or 8 hours, right? So like, how the fuck does that work? Well, it turns out that if you have to work 8 hours every day, like you're not getting, like I don't believe that I was getting more done as much as I was just taking more time to do the same stuff, right? Obviously 2 hours is maybe like an exaggeration, but definitely like 4 to 8. I'm certain that I can accomplish the same in 8 hours in 4 hours that I was accomplishing in 8 of work, as long as you're like focusing. But I mean, everyone's different, of course, as well, so who knows. Okay, so I guess here we have like selected object here as like a thing, and that lives in the composition object. So I guess following that logic, our path object might have like a selected point as an index into here. Maybe. Sure. So, I mean, arguably you only need a selected point for the active path, but I think that it's going to be easier for me to manage the data if it's just like, do we have a path object? If we do, we'll find the selected one. And then we just do like select closest point like this with point as a vec2. So we're going to go like for self points. I don't know why I typed a void there. We're going to like look at the point. Okay. And this is going to be, I guess, like test pause where like, sure. Total aside, my website uses shaders that are mixed on layers that work exactly at Photoshop. Great minds, that's funny. Same shit, same shit. So we're gonna look at like each point, and we're gonna say min dist is gonna be stud math in f32. Right, we're gonna have like closest point is equal 0. We're gonna like calculate the dist, so it was gonna be like length squared of test pause minus point. And then we just go like if min dist, if dist is greater than less than min dist, closest point is equal to index, and min dist is equal to dist. And this looks a lot like closest object finding. So there's probably some sort of deduplication to be done here. But I'll kind of tackle that later. And then all we have to do is just look at the closest point. So self selected point is equal to closest point. Wow. Okay, so now we can do some sort of like mouse move adjustment, right? Maybe for now, can we like just render the selected point as well? So can we do like point size 50 for one point? That's gonna be like select it. We have like a selected point. We're gonna look at the selected point times 2 as the offset because they're no, just selected point, and we're gonna render one of them. Yeah. And then here we can take in p selected point. All right. And then probably there needs to be an incast in there somewhere. Probably like here. So we go here, we create path here. One of the points is like mega big, and clicking does nothing because we didn't actually call set selected point anywhere. So here we have to like kind of look at the current object. And I guess the composition object selection should live in the composition object in the same way that the selection code for the path lives in the path up. So we're gonna say like pub function, was it set selected? What do we call it in the path object? Select closest point. Okay. And I guess we're going to do essentially the same shit. Composition object, self, self, self. And then we have to call the input point. What do we call it here? Mouse pause. So test pause is here. All right. So now we can go in here and we can say, yo, depending on what type we are, like if we're the composition object, we just go C set closest point to self mouse pause. Otherwise, if we are a path, we have the same thing. Nice. And then I guess on mouse up, I guess we do want to have the same behavior in the path one, where if the mouse is not down, we have nothing selected. That seems pretty reasonable. To be honest, so we'll say like, I guess we could just do manually, whatever. So here we'll do something similar, except it's just like C selected object is equal to null, or P selected point is equal to null. Else we do nothing. Same with this. All right. Sure. So he's probably pissed about something. Really? Composition object does not have a selected object? What does he have? Selected obj, sorry, of course. Of course. And then at 169 now, we need to go like the render function, I guess, should take in this as usize, and we'll just say if we have a selected point, then we use it. Okay, closest point equals 0 at 721 is mad, sure. Okay, self points 724. Fine. Okay, so oops, what am I doing? I'm trying to resize this. I'm trying to go here, create a path, look at the path, click here, okay, click here, click here, click here, click here. Looks like our path selection is working, and now we just have to kind of like edit the path. So we have edit path points. Edit path points. Okay. So what's that look like? It's going to be like our path object is going to be like adjust move point. And he's going to be like, here is the like movement. Okay. And he's going to be like, if we have a selected point, I guess we go like IDX is this, else return, okay. And we're going to be like self points items at IDX plus equals movement, simple, right? And then all we have to do is like re-upload the data. So we're going to call like GL buffer sub data. And what are like the arguments here? GL buffer sub data. So we have the target, which is array buffer, probably. We probably want dynamic draw here when we created this thing, right? Because if we're changing the data, we need to like let the guy under the hood know that's going to be changing. What is the fucking function call here? Usage is like here we go. Okay, so there's draw and read and copy, and then static and dynamic and stream. So this will be modified once and used at most a few times. Data will be modified once and used many times. Will be modified repeatedly, used many times. So that's this one. So we're going to be dynamic, and we probably want to draw. So let's just kind of change this to this. And then we want GL buffer subdata, which takes in the target, which I think is the same as we put here. Array buffer. And okay. Buffer is the buffer object. So this is going to be like self vertex buffer. Okay. Offset specifies the offset into the buffer object's data store in bytes. Okay, so this is going to be self selected point times 8, 2 floats. Yes, and we are going to specify the size in bytes of that thing being replaced. So this is going to be 8 bytes. And the data is going to come from self points item self selected point, and just like the address of this thing, maybe. Okay, and then I guess on mouse move, we're going to do the same thing here, where depending on which like view we are in, path we're going to call like p move point with new pause minus the old pause. And for the composition object, we'll factor this out later. But we'll just say, you know, slap this shit in here for now. And then we'll put like a fix me move into composition object. Okay, move this code into there. Okay. So he's mad because GL buffer subdata expected 4 arguments found 5. Which one of these things did I do wrong? Offset size data. Oh. There's like the named version and the unnamed version. Does that work? Oh, because now it's not target, it's buffer here. Okay, got it. And then he's mad because selected point is, we're supposed to use IDX here, the extracted thing. And then this is IDX as well, like this. Okay, and then he's mad because we need to int cast this. Fine. All right, so we create a path. Oh, wait, that actually fucking works? I did not really think that that would do it. That actually works a lot better than I thought it would. Sick. That's pretty cool. Pretty cool. Okay. So now we need a way to like edit, like add things to this path. Right? So what are we gonna do there? Maybe we'll say add path points. Maybe we'll just say on right click, a new thing goes there. For now, it's not ideal, but it's good enough. Good enough. So we'll be like control click delete a point. Maybe. Yeah, we'll see. Or maybe we will try to how to say this? I'm not sure how I want to handle deletion, so I'll think about it. Set right mouse down, or right mouse click. We don't have to handle like down and up. We're not handling any drag there right now. click right mouse. Fix me should, like, I'm not really sure if this should be based off like actions more than anything. Like, should UI ask for something more specific? You know, maybe. But for now, we'll do it this way. So let's just do this. And if we have a point, I guess we'll call like add point at self mouse pause. Okay. And I guess this is literally just like points append. I guess we need an allocator here. And then we need to update the vertex buffer. So if we are adding a point, now we need to basically do this. Right? We have to rebind the buffer. Unless GL buffer subdata can like fully replace. Which I don't think it can. So yeah, we'll just do this again. Can we do like update buffer data? If an image manipulation program doesn't support moving selection by holding spacebar, I get really upset and consider going back to Photoshop. Okay. Well, you can write your image editor to do that then. So this is going to be a CGL uint, and then this is going to take in the points as probably a vec2 slice. Probably const is reasonable, and then here we just say we bind the vertex buffer, and points now is not points.item. And this is going to be set buffer data, I guess. Create, yeah, set buffer data, we'll call it, fine. So now we have this is set buffer data as vertex buffer, and points items here. And now when we add a point now, we can just be like, yo, reset that motherfucker. Okay. I guess our UI needs to send a right click somehow. So how do we do that? We have some sort of like mouse button callback here. Here we write to a queue of window actions. We'll just kind of do right click here, and we'll say if we're looking at the left button, then we queue. Okay, so if the button is this, then the right obj, I guess this and is down. This is a mouse up. Okay. Else if button is equal to right, we have a mouse click, or sorry, right click. And then we also have the case where we are looking at the left and is up. Not is down. Okay. Then the other scenario is that this is like unset. And then we can say if right obj this, we do this. Okay. Seems reasonable. Seems reasonable. Then we have to handle the mouse down thing. And then this also has to be variable. Use the non-name variants of signals that you want to support earlier OpenGL. Use of the non-name variants of signals that you want to support earlier versions of OpenGL, but then use the name variants breaks things for less than 4.5. Oh, I see what you're saying. There's compatibility issues. Yeah, I don't really give a shit because I only have to work on my machine. The joys of writing software for myself. See earlier comments. There is a GL name buffer data, by the way. You don't need to use GL bind buffer. It's kind of weird to see. Oh, named and sometimes not. Oh, my bad. You're right. Probably just because I copied in some places and didn't in other places. But yeah, I do kind of agree with you. It does kind of seem better. Does kind of seem better, huh? Okay. 716. We are supposed to write try here. Okay. Probably not, though. Probably set buffer data just can't fail. That's way cooler. For sure. Okay, then in main, we have this new right-click action to deal with. So we do app dot click right mouse. Okay. Member function expected 2 arguments. I think it was the allocator, right? Yep. Okay, and then error union is ignored at 104, so that's here. Okay, error union is ignored at points append. True. And then here we're probably supposed to put this in a block to avoid unused results. Expected type void found. Oh, he's mad because this thing can't fail is probably more reasonable. Sure. Did I not save here? I always forget to save. Okay, let's see it. Create new path. So we have this. He's mad about something. It seems like it's like spamming right-click mouse. Hi, Mom. So I must have fucked up my like if statement here. Yeah, I fucked up something. It's also like not releasing anymore. Oh. Okay. Is that better? So I go here, create path, look at the path. The positioning update seems wrong now. I don't really understand how what I did here changes anything, to be honest. Yeah, something what the fuck did I change? Oh, too much we didn't checkpoint. Okay. Does like the other, like if I'm in like the composition view, this feels okay. The path creation stuff does not. It almost feels like it's rendering in the wrong spot. Which could be from the buffer sub data. Right, we did change this. Can we put this back? Oh, because maybe the buffer wasn't bound. When I set the array object anymore. Because it kind of was like implicitly getting bound before. Could be it. Could be it. Yeah, that looks a little better. Right click. Okay, so that's looking pretty good. Now we just need a line strip instead of lines. Create new path. Boom, 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 boom. All right, that's looking pretty good. Yeah, that's pretty sick. For now, since the only point of a path is for generating masks, I think that we are going to have an implicit wrap. So how do we do that? I guess we don't have to draw that. We can kind of like, because we would need to make like a second vertex buffer with those 2 points, I think, which I don't really want to do. What are you guys talking about over here? Yeah, you guys are talking about open source software. Most people will say, I don't know how to code, and that they should pay someone to do it for them. And they complain that open source is supposed to be free of charge. Yeah, I mean, I don't think that what I do is open source. I think that what I do is I like post my code online and say, do what you want, but I don't want to be involved in like what you guys do. Line loop? Oh, that exists. If that exists, that does just solve my problem, huh? Create path. Boom. Oh yeah. Oh yeah. That's pretty sick. Thank you. Okay. Okay. So now let's figure out how to like generate a mask, huh? I guess maybe before we do that, let's try to make this thing savable. So that we don't have to keep regenerating our path after we outline something one time. But statements shouldn't cross no. What are you talking about? But statements? Okay. Oh, but with one T, segments shouldn't cross no. I think that they can. I'll have to think about it. I think that I'm okay with like the idea of right, like if I do something like this, right? I think that's like not an unreasonable mask to want to create, right? And I think that the mask code will just kind of like consider this like 2 triangles essentially. I don't see a problem with that. Okay. Well, yeah, let's fix saving. So I think that right now if we hit like save now with a path in here, it crashes because at 586, actually hold on. We'll call this path checkpoint. Where's the crash? It's at 586. Okay, so on here, we just need to figure out how to like serialize this thing. So what does our path object look like? We probably need to keep these 2 things and nothing else, right? So where is our like save object here? Data, we have path. And we just save the parts we care about. So it's this, boom. And the points is just going to be a list of vec2s, which I don't know if we can serialize. We might have to get a little clever here. We'll see. And display object is a usize. Okay. So now, presumably, somebody else is going to be mad that we don't compile at 586. No. 596. Right, so on load here, we have to like construct our thing. And what are we doing here? It looks like we're creating a data thing. So it's going to be path is going to be some sort of like path object initialized with, I don't know, display. This thing takes in a initial points, which is going to come from here. Okay. Then he's going to look at the display object, which is going to come from p dot display object, probably. And then what else does this thing take? He needs a vpause location. Okay. So this doesn't come from here. Where does this come from? We're gonna need to take in like a path vpause lock, I guess. On load, which is gonna be like path vpause lock. Okay. So then who calls this? Here. Okay. Should be fine. He's mad about 620. We have strong typed object IDs, so that's probably why we had this before. That's fine. It's fine. We have to do the conversion to real conversion to strong types at some point. Sorry, somebody was asking for doing anti-aliasing support, and then somebody else was like, well, if we input it, we get there, so being an asshole. Yeah, I feel like probably initially no on anti-aliasing support, and then eventually we might do it. I don't know. I have to think about, like, it might be that the mask that's generated is not anti-alias, and the shader can choose to do some sort of blurring if it wants, right? You could do like add a box blur to your mask after the fact if you feel like it. I'm not really sure. I'd have to think about it. And if the default, if we don't think about it, is that it won't be. And we probably just won't be. we don't think around here. We just do. This compiles, right? Yeah, it does. Okay, so now we have to do the save side here. We need to construct one of these things. So path equals something like this. I don't know. What's in this thing? Points and display object. So this comes from p display object for sure, and then the points comes from like p dot points dot items, I think. And I think it just kind of works for free. Expected use size here, so we do need to extract the value of the strong type. I mainly wonder how it should be done to be accurate, but color sense is a bitch. Yeah, if we just don't think about it and we say users who write shaders have to think about it, then it solves our problem. It means that we don't have to worry. Okay, so let's see if this kind of works. So let's say that we're going on this thing. We have created some sort of loop. We hit save, we close, and then we load that save back. Sick. That's pretty nice. Love it when shit just kind of works. Love it, love it, love it, love it. Okay. So now, what is next? I guess that's save support done. And let's try to make a mask from the path. So, I don't really know what I don't know if it's like trivially easy to fill in a polygon, but I know what I would do to fill in a polygon. I think that you can just do like, you know, if you have something like this, you can go line by line and kind of just say like, oh, if I see this thing, then I'm inside, and if I see this, then I'm outside. And you just kind of like iterate the thing. And every time you see a line, you go, oop, gotta flip, right? So what I'm imagining here is like you could do like line intersection, right? Like you could do like something where you go, okay, I'm here, this is my pixel. And if I cast a line from the left side of the screen, how many times do I like intersect a line? But that's kind of like stupid if we are generating this on the CPU, which I think we are. What I think makes more sense is we can like, for each line in the path, write down the X position that it crosses, right? So for each line, right? So like from here to here, 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 we know if we just look at all of them for the given line that we're on, there is like either 0 or 1 points where it goes across. And I think we just write those down and then sort them. And then as we like construct our mask, we can just be like, oh, okay, we see another one now. So that's kind of the plan. That's the plan. I think I'm gonna do the CPU side because I don't really know if it makes sense to do a GPU side. It might, but then this idea of just like going from the left-hand side to the right-hand side and counting how many times you hit walls doesn't work anymore, and I would have to be a little more intelligent. I think also probably in the future, I probably want to turn this into like a signed distance field. But I don't really know how to do that right now. But using it to be like, being like SDF would allow downstream users of the mask to kind of do like more interesting things, right? They would be able to do like um you could easily dilate the mask by just like changing your threshold to like -2 or -3 to go like farther out, and then like you could also like adjust. You could like kind of like feather the edges, right, by like saying that the alpha kind of goes up, linearly interpolates between some sort of like SDF values or whatever. But for now, I think the easiest thing to do is just fill in the mask by hand. I think we have to start somewhere. So let's see. I guess we kind of did path editing already. That's kind of done. Okay. Yeah, so let's do a commit here and say this is like, I don't know, path saving or something. And okay, we now have like a new object type, I believe. Right? We have like a path to mask type, which is kind of interesting. Mask, generated mask maybe. And the reason I want to store it this way is because I want to be like, later we're going to link all these things together. And so like a generated mask object that has some sort of generate function that comes from the path, I think will be useful. I think it will also allow us to display like different metadata. And I think this thing is going to look a lot like a file system object, to be honest. But I don't really know. Let's see. So I guess generated mask object is going to have a texture, right? This texture we're going to generate when the path changes. So I guess the source here is going to be an object ID. Okay. And there's probably a generate function here who probably needs like a size associated with him, right? The mask is going to be put into like pixels. And so this thing needs to have like a width and a height. Right? What are you guys talking about over here? Kind of depends on what color values represent. At least in 3D, they usually represent light intensities. Then you want to do interpolation of linear RGB, blah, blah. Are you talking about color space stuff? Closing my eyes and blocking my ears. I don't want to think about it. So we have like a make texture from RGBA thing that exists. So I guess we're going to start by allocating something that has a width and a height and 4 pixels, which is maybe kind of stupid. Maybe we should have make texture from R. Yeah, let's do that. So we'll have like a thing. So const mask is gonna be an alloc of width times height. U8 probably is fine. You might be able to get away with like bools or something, but for now this is gonna be good enough. Okay. Then we are going to, I guess we need like a source path. Maybe path points, and we can just look at like a bunch of vec2s. And then we are going to like maybe like find the bounding box of path points. We'll probably start by mem setting the maps to 0. We find the bounding box of the path points. Okay. Then we walk bounding box. Then we find, okay, we're gonna be like const bb is equal to find bounding box of path points, right? We're gonna have like for 0 bb y start to bb y end. We're gonna have some y value. Then we're gonna go for the x values in here, right? We are going to like find the intersection points, right? Is going to be like find intersection points of path points and the x value, right? Now, this is kind of interesting because the bounding box has to be in pixel space, so we actually need to pass in the width and height in here as well. And these are going to come out in like normalized coordinates, I think. No, these are going to come out in pixel coordinates. Okay. We're going to find the path intersection points for this line in pixel space again. And then once we have those, we can say like, we can just go in like intersection point chunks, right? So we'll assume we start outside. And if we're just trying to then go in chunks, we go 4, 0, or 0 to intersection points len over 2. We're gonna draw. We can figure out like the row is gonna be like something like what? It's like mask row start comes from the width times y. Row end is row start plus width. Okay. Then we have like the row is the mask from row start to row end. Nice. And now we can just go through these intersection points and say row from I times 2 to I times 2 plus 1, I think is how we want to do this. This will be, we're trying to do it in pairs. So we have start, end, start, end, start, end. Yeah, so I think that's right. I think that's right. So we can just memset this to max value. That feels kind of right to me. So now we have this like mask, and then we're going to be able to do like texture, like make texture from R. And we'll pass in the mask and the width. Maybe use dynamic bitset for mask. I just don't know if like, I don't know what like the OpenGL types are going to be, right? So I don't know if there's like a way to pass in like a packed mask and get it out as like a sampler, right? Because really what I want is like a texture that will automatically draw white here. But you know. Hey, Sir, my brother talked to me about you. I've been dabbing into Zig lately, and I just want to know, is it fine if we ask you a question about it? You can ask, but I might not answer. I'm not really here to be your teacher. I'm here just to like stream myself, and if that's helpful, it's helpful. If I feel like answering, I might, but I'm making no promises. I probably won't. You know? Okay. So, where do we want to start here? Probably we stub out these functions. Yeah, let's start by stubbing it. So, find bounding box of points. This should be pretty easy. Bounding box. Right, so this should be like y start. Literally everything should be U size here, I think. Right? And we need the width here and the height here. So here we have points are in -1 to 1. So do we have like pixel? We have some sort of like mouse pause. Coordinate conversion window to clip. So this takes in my X position in pixels and returns back the clip space thing. So I think that's like kind of the same thing here. Arguably it needs a rename, but I think it's the same idea. So we have like window to clip. But how does he know the width? Oh, he calculates those manually. Can we do like... Can we change this to take in the width and the height here? And I think then this kind of just becomes generic. Like this. Window to clip now then is just going to have to take in self window width and self window height. Just want to know if there's a reason why the type can be inferred from assigning the results of a cast to a variable or constant, but not if I operate on it with something else of the same specific type, like F32. My guess here, it really depends on what you're talking about here, but my guess would be that the constants, if you do like const x equals 1, x has a type of comp time int, right? And comp time int can auto cast into float, into usize, into like i32, right? Because like the compiler knows that this is like, it knows that that's like a thing that it can do. And if it can't do it, then it just won't compile, right? But if you have like x as a usize, right? X usize is equal to 1. Now all of a sudden the compiler, like, I don't think remembers that this came from a constant. It probably could. I'm not really sure. But in this case now, you have to do an int cast to go to any of the size, because like you need to do runtime validation to make sure it's sane. That would be my guess. But I just made that up, right? Don't really listen to me. I don't know what the fuck I'm talking about. Okay, window to clip using. So I guess here we're gonna go over each point, and we're gonna convert each point to window to clips for. Oh, this is window to clip. This is backwards from what we want, isn't it? We kind of want clip to window. Okay, we'll figure this out. We start with like stood. We'll start by like finding the positions in normalized or clip space or whatever the fuck we want to call it, and then we'll convert at the end. So what am I gonna do here? If point 0 is less than min x, min x is equal to 0.0, and this is y, and then we do everything here is like max x, max y, and then here we need to do ones for y's. That's right. Min x, min y, max x, max y, max y. Yeah, seems good. Seems good. Okay. So now we like have our bounding box, and we just have to say that we just have to do the math here. So it's gonna be like, we'll just do the opposite. Clip to window. So we have x, y pause, y pause, width, height. And so I guess we just do -1 to 1 goes to width. So this is going to be like x pause plus 1 over 2 to get from 0 to 1 times width. And we do the same for y, except y is inverted. So y pause plus 1 over 2 gets us 0 to 1, and then we just do the 1 minus here before multiplying by height. Okay, I think that's right. Width f, height f. And then this thing is not going to return a vec2. He's going to return like a usize, I guess. Okay. And then what are we going to do? We're going to like round maybe, and then int from float or something. I don't know. Maybe we'll just floor it. Fuck it. I don't give a shit. we'll see what the consequences are from that later. Fine. Fuck it. I don't know. Yeah, sure. Start y is equal to clip to. I guess we want like a min is equal to clip to window of min x min y, width and height. Max is the same with max x max y. I don't know, man. I'm sure this will fall over some places. I think they're really with like out of bounds checks to worry about. There's probably some sort of like clamping that we have to do, but for now we'll just do it like this. And then I guess maybe we can return I64s here or something. And that will be a little bit more sane. Then we can return a bounding box that's like start x is equal to stood math clamp 0 to width of val, so min x. Okay. And then we intcast this to a usize. Start y is the same with y and height. And x is going to be max. And y is going to be max y. All right. All right, so that's one piece of the puzzle done. Now we just need to do find intersection points. Okay. So we're looking at some sort of list of vec2s in floating point normalized space and some like y value. Right? And I guess we are returning like a list of usizes. Right? Don't you need to turn last with height? Yep, true. Good point. And I guess maybe I64s here make sense because there might be things that are like out of bounds. We might be off the edges. Okay. So like what's this gonna do? We're gonna look at, we have the special case, the wrapping point, right? So the last point in this array is going to be connected to the first point. We have to handle that. But until then, let's kind of figure out what the other things are going to be. So we're probably going to have like an array list of points. Maybe not. We kind of know how many points there's going to be. Right? This is like pretty much guaranteed to be points.len. No, it's not, because some lines will not cross the x position, this row. Okay. So I guess we need an array list of I64s. Okay. Intersection points. I guess this needs to be variable, and we need to eventually like free this thing. We need to return intersection points to owned slice because it's not modifiable anymore, but this does take an extra allocation, so maybe it's not worth it, but shut the fuck up, whatever, I don't care. Points now. Okay, so we go like, so for 0 to points len, we can go 1 to points len or 0 to points len minus 1, doesn't really matter. We have A is points at I, okay. B is equal to points at I plus 1, or sorry, yes, I plus 1. Then we're gonna like, the Y position, we need to find the Y position in normalized space, right? That's kind of how I feel. So we're gonna be like const Y norm, or Y clip, I guess. And we'll call this Y pixel space, or Y pixel space. This is gonna be like a window to clip. of just y. So we're gonna have to fix this later, but you know. Fix me split window to clip into XY components. Right. So this is gonna be like this. And I guess now we are going to have to like lerp this somehow. So we have like for each point, we have like the interpolator value between A and B is going to be like our Y clip minus B over A minus B, right? So if Y is between A and B, right? So we have like A, B. We have like a couple options, right? One is that Y is here, right? So this is going to be this distance over this distance, right? Which is fine. This will be between 0 and 1. If it's over here, we're going to have like this distance over this distance, which is going to be greater than 1. And if it's down here, it's going to be negative over positive, and it's going to be negative. So we just now need to check if t is in the range. If t is greater than 1.0 or t is less than 0.0, we have a fucking problem. So we just like nope the fuck out. Otherwise, we just do a std math lerp of A to B and T. Except we only want to lerp the X values. Right? So this is the position in X clip that they cross. And then now we just have to convert that. So I guess we need to take in the width here as well. So we need to do clip to window, X clip, Y width and height, X pix is equal to this, and fix me split XY. And now what? Now what? I guess we push into the intersection points. So we need to incast this probably. Try, put a semicolon. That's like a maybe that works. Okay. Now we just have to make texture from R. So make texture from R. Okay, okay. Dude, can you imagine if this works the first time? That would be crazy. Okay, so we have some sort of like common code here that does all of this stuff. Okay. Then this calls const texture is equal to make texture common. Boom, all this goes away. Same here. And then we're basically going to do something similar to this, except we are going to say that the source data, I guess we can just get away with like single channel on both of these, but otherwise it's the same. And the height is no longer divided by 4. Seems reasonable. Seems reasonable. Okay. So this is make texture from R. All right. So now we have like an object ID and a texture. So this is just source is equal to source. Sure. And now where is this thing fucking used? How much do we not compile right now? We should probably, let's start fixing this. So 598. Let's start doing like generated mask is undefined. Just kind of start slamming this shit around. This is on load from save object. So save object doesn't have it yet, but on save we need to give the fuck up. Then we have 159. We have to handle this generated mask object at 211. We have another one in main. So let's just do for now generated mask. Okay, who else is mad? GLUint at 491. He does need to return the texture. That's a really pretty good point. All right. And I guess when we create a path, I think we kind of like we just kind of say every path will be a mask for now. I think that seems pretty reasonable. Which means that when we like update the path, we have to update the generated mask, which is a little annoying. But that's okay. We'll figure it out. We'll figure it out as we go. What keyboard do you have? It's really silent. It's not quiet. I just have a noise gate. Let's see if we can find it in this like list of shit. Yeah, so the mic goes into a compressor and then into a noise reduction thing. And then that goes into a bunch of shit into OBS. So yeah, I just have a cherry browns, but it's not what you hear. What you hear is way different. Okay. So I saw this comment from Lug, as core is dev in Discord. I've been vaguely cooking up some potential improvements to RLS to make math easier. What's RLS? I assume that's like some sort of part of the like Zig compilation pipeline. Okay. Yeah, so let's try to make this mask. Well, actually, maybe we limit our exposure right now. Let's just see if this compiles right now. Do we compile? Oh, we do. Okay. So if we compile, then let's try to add a generated mask object and see where it fucking falls over. So this is going to be generated mask like this. And we call this generate. And he takes in allocator source. So we'll call this path ID is going to be self objects next ID, which means that he has to go up here before you append. Then we can pass in the path ID here. Okay. Width and height come from somewhere. For now, I'm just gonna do like 100 by 100. We can like, we need to like define. Probably like the mask size should come from the source, should match the res of the image it's coming from, right? That the path is like attached to. But for now, we don't really have that information available to us right now, so we just kind of cheat. And then the path points are just going to be like, can we just do like a const path ob just equal to this? And then we can write path object points items here. Okay. So now he's mad that find intersection points is not using the right thing. So he has points, y, width, and height. Okay. And we're still mad. We were missing an argument here. Allocator. Okay. Min x, he's mad at 873 that we try to assign some constants. That's true. Little whiner, this guy. Start x is mad. What do we call it? X start. We have these flipped. It's x start. y start, x and y end. All right. Min x is supposed to be 0 and 1 because these are not named. Okay. Y pix is supposed to be u size, so where was that? That's like here. Float from int. And then I assume, is that kind of everywhere else is good? Y clip minus b. That's true, because these should be using just the y coordinates of all these things. Found out of memory, so this thing needs to be able to fail, so this needs to write try. Incompatible types i64 and u size. So this is probably in clamp. Okay. Can we do int cast here to an i64? Int cast width and height i64 is height, and then here we say w i64 here and here. All right. All right, that's not a complete dud. Let's see how fucking fucked we are. I guess we need to start from somewhere. So let's create a path here, and then he immediately crashes because integer overflow at start to end. So that means that end is less than start here. Okay. Let's see what's going on there. So that's on bounding box selection. Right, because the y is inverted here. Okay, the normalized space on y is flipped from pixel space. So let's try this again. Let's create a path. Okay. So now the mask is kind of empty, but it kind of makes sense that the mask is empty because it was only a single line. I would like to save this, which doesn't work. And then maybe, like, I guess what we should do is we should make it so that when we add a point, that the mask gets regenerated. That's kind of the play we need to make here, right? So here on when a path point is added, we need to regenerate masks. We need to like find masks that rely on path and regenerate them all. I'm gonna do this here as well. Right? So I guess we're gonna have like some sort of helper function that's like regenerate masks for this path ID. Okay. He's gonna be like, I take in self, an app. And he's gonna be like, for, I think we have like an object ID iterator or something. Yeah, we do. So we're gonna say var iterator is self objects ID iterator. While IT next, we get some sort of object ID. So then we have the obj is going to be self objects get ID, which I think will return us a pointer to an object. Nice. We switch on the object and we say if it is, I mean, you could even get crazy here. We could make this like regenerate dependent, but for now we'll only handle masks. So I think we switch on the data here. And we say if it's a generated mask, we do one thing, else we continue. And I guess in here, we're literally just gonna say generated is equal to this. Okay, now we have a mask, and we just say mask is equal to generated mask object generate. I guess we kind of do it like this. Temp is this, and then we swap them. Defer temp dot dinit, which doesn't exist yet, but surely he needs to. this needs to be Alec Freed here. And then on D init of us, we just have to delete our texture. And this is a generated mask object. Okay. So then here we're going to be like, what does this give us? This is going to give us a pointer to the object, so I think we're chilling. So then we're going to be like, init this motherfucker, and then std mem swap it from like mask to temp. I think this is what we want to do. And now we just have to figure out how to like generate this thing. So this is gonna like take in an allocator, object ID, a width, a height, fix me, width, height should come from source. And then was less thing path points, so path is equal to switch on, I guess it's path object here, comes from self objects get mask path ID, something like this. Maybe source, nice. Const path is equal to switch path obj data, and if we do not see a path, this is a corrupt, we have some sort of memory corruption. So else we panic invalid mask object. Maybe this should just return invalid mask obj for now. Okay. And then here we can look at the path points items. All right. So there's no mask now, but can we check if we are like regenerating this thing? Regenerating mask. I think we are not, because I don't think we actually called this function anywhere. Which would kind of do it, huh? And then also like our render function should just crash. So the fact that it's not is a little confusing as well, but we'll get there. We will get there. So this is on add point. We need to regenerate objects from self-selected object. And we need to do that here as well. Okay. $226 is mad because this thing needs to take in a generated mask object as its type. OpenGL never crashes. It only occasionally works until it doesn't tell you why it went wrong, though. Yeah, especially when we don't set up error callbacks. I think every time I've worked in OpenGL, you're like, bro, set up your error callbacks. And I'm like, no, you can't make me. Area news ignored at 141 in linter, I guess. Yeah, because this thing could fail now, so we will allow it. Okay, so we create a path. So like what's bothering me is like, I feel like we should be crashing. Can we, oh, that's not good. We're kind of regenerating the mask whether or not the point moves. But we can live with that for now. For now, we should fix that. But we'll put a fix me here that's like maybe we actually, it's probably easy to fix here, right? We can just be like, if self mouse pause we only want to do this if the mouse is down, right? So here it should only happen if the selected point is valid. That should help. I'm the designated GL debug message callback town crier. Yeah, perfect. Okay, so we create a path now. Now it's not spamming, but now he's regenerating the mask whenever we move this thing, which is good. But this is, again, why is this not crashing? Because what we should be seeing is on render object with transform, we should be hitting here. Is undefined. What's the difference between undefined and unreachable? Maybe undefined is wrong. Maybe it's just like kind of not crashing like I expect it to be. Yeah, there we go. I was using the wrong fucking flag. Okay, so how do we render this thing? I think it's literally just we render. I think it's just like self program render with the texture. Right? And then we need a transform. So I think we just pass in our transform. And I think that's probably it. So can we see, we go in here, we create a path, we go boom, boom, boom. Okay, so what is the next point to debug here? It is probably to try to render out the generated mask and look at it without any of the OpenGL stuff. Probably. Can we like, or maybe we can even just like print it. I think we have like, I think we have STB image right in here somewhere. Yeah, look at that. All right. Can we just like write this thing out? Write PNG. So we have width, height, int cast width, height. What else is in here? Components 1. Data is mask pointer, and then the stride is just width. Right? Because it's 1 byte per pixel. Okay. Can we ignore this for a second? And we probably have to link this thing for now. Do you use your job? Technically, you could argue this is my job, so yes. But I would no, I do not. I do not have a job. Okay, so now he's like slow as shit because he's trying to write this shit out all the time, which means that we should be able to look at test PNG. Okay, so that's not good for sure. For sure, that's not good. That doesn't look like what I wanted at all. Can we maybe it makes sense for us to start looking at like the bounding box and stuff? So can we say like std log debug found bounding box for path is this. Let's start there. And then maybe we log the intersection points too. Intersection, nah. Okay, create path, new path, edit. So our bounding box here is start. Oh, these are in fucking, these aren't in pixel coordinates. Hello? Oh no, they are. It's just 25. I thought was 0.25. I just can't fucking read. Okay, let's try this again. So we're expecting out of 100, right? So if we go over here and we put everything in the left side, we're seeing x2 over. If we move to the right, we see like x100, y at the bottom, we see y100, y at the top, we see this. So I think the bounding box is kind of correct. Now, then the problem is more. It looks like the y values of this are kind of right too, right? We can see the triangles in the bottom left. It's just only putting pixels on the left side. So there's something wrong here. So can we look at like the intersection points? Presumably, they're just like a bunch of zeros or something. We're probably doing something fucking stupid. Okay, so can we create a path? New path. So here we should be seeing the majority of points with 2 intersection points. In fact, they should all have 2. But it's probably not counting one of the lines. So what if we do kind of like something like this? Yeah, okay. We forgot to handle the wrapping case. So let's see. We could do this for now. I don't really want to split this out, so I'm just saying like if B is like if I is equal to points.len minus 1, then we get points 0 else this. And then fix me split out iterator or something. Split out to avoid if every loop. I hate seeing these loops this way. They piss me off, so it'll fix me there. And let's try this again. Okay, so create path. So now it looks like our mask always has 2 intersection points. Oh, I guess and they're identical because there's like going there and back again. A Tale by Bilbo Baggins. We need to sort the intersection points, which is probably not helping, right? So probably if I put this on the right side, I bet you we start to see something. No, interesting. We should definitely sort them though. So let's do that. Mem sort. We have like a type of I64s. And we're looking at these items. Okay, and then we are looking at some context, which we don't really need to give a fuck about, and then like less than, we need to define some sort of less than function. Which will follow this API. Okay, so this is void I64 return LHS less than RHS. Boom. All right. Was that a Tolkien reference? I thought only nerds read. Actually, I forgot there's a fucking ton of movies. I mean, I did read The Hobbit. The Hobbit is like one of the only books I've ever read. Every year at school, I would read the same 3 books, and The Hobbit was one of them. Because like every year at school, they'd be like, "You have to read for this class. We have reading time." I'm like, "Okay, I'll read The Hobbit again." And then like it's like the only book I ever read. But also, yeah, it's in the movies. In the movies at the beginning, he has There and Back Again, A Tale by Bilbo Baggins, and it's been stuck in my brain ever since. Okay, so these intersection points do seem reasonable, but then the mem set of them does not. So what's going on there? So we find our intersection points, we log them, we look at the, assume we start outside the polygon. So can we just say like setting this to this. Like, am I doing something fucking I times 2 I times 2 plus 1? Oh, I'm a dumbass. We need to use the intersection points. You know what, guys? I don't want to hear it. I don't want to hear it. I have to use the code I wrote. Do you know how many times I've had to say you have to use the code you wrote? Const mask start or row mask start I don't know. A. Shut the fuck up. Intersection points at I times 2. B is I times 2 plus 1. And then here we need to do a U is a U size is equal to a int cast of stood math clamp of 0 to width of A. Is it which way clamp takes in the value first? Which means we need like width I64 probably. Const width I64 is a I64 is equal to int cast width. Okay. And BU takes the same shit, and we need to go from row AU to BU. Boom. All right, let's try it again. Create path. We have a triangle. No mask, but what if we refresh here? Okay, wait. That's definitely something. Right? I mean, that resembles this in some way. It looks almost like backwards on X. Right? Like, what's going on here? I move these points all to the right side. It's okay, so it's like on the right side for sure. It's like the overall structure is kind of following us correctly. It's almost like I actually like really don't understand what I'm seeing here. It's like Y is inverted and X is inverted. What in the fuck? Within the pounding box, but path is inverted. Yeah, it feels something like that, right? Because like if I pull this out farther to the right, it like the point is still like staying on the left side of the bounding box, which is kind of fucking weird. Kind of fucking weird for sure. I mean, so that kind of indicates that like the intersection points are like almost right. Clip to window. Is this backwards? I don't think so. Okay, so how does this happen? We memset true for the first to second point, right? So we're going like from 16 to 38. That almost feels wrong. Like, why is it like kind of staying at like 16, 15 the whole way? Right? So let's like make a triangle here and we'll kind of bring it all the way to the left. No, I guess, okay, that's kind of, what if we like invert the shape here? So here he's seeing that like the right edge of this is saying like consistently 47 to 48, which seems right. And the left edge of this is kind of starting small, ripping its way upwards, and then going back down. So that's kind of wrong, right? That kind of lines up with the fact that we're seeing like the inverse of this triangle almost. Which means the lerp is probably wrong. It makes me think that this lerp is incorrect. So can we look at this again? We're trying to lerp between A and B X positions at time t. And we're looking at ourselves relative to B. Maybe we need to look at ourselves relative to A. You know, we're just spitballing here. So let's make this triangle. And what does it look like now? Garbage. So maybe not. Is it something to do with the fact that like Y clip is upside down? Could be. Do we just need to walk in the other direction? I don't think so. It's like, if we do, it doesn't make sense to me why. So even if that would fix the problem, I would like to understand what I have done that is not what I thought it is. Right? Window to clip. So we look at our Y pixel. Can we do like std debug print Y clip is this value? Let's just kind of start here. Y pixel goes like this. So we expect Y pixel to be growing and Y clip to be shrinking, because in Y clip space, we should be going towards -1 in the bottom left corner, I believe. So like if we, let's just kind of make this like small. So we should be starting at like small values of X, of Y in pixel space, right? So we're going Y pixel space is like 3 to 18, which is chilling. And then the clip space starts from like almost 1 to almost not, to like, yeah, see here he's going all the way down to like -1. So that clip space conversion feels kind of correct to me. As he's walking through here, we're going like 7, 8, 9, 10. Yeah, it's this is backwards. It's the first intersection point is wrong. The second one seems okay. The first one seems wrong. So why would that be? So we're trying to find this lerp. We have B, A, Y. Right? So we are finding like this distance. Oopsies, what did I just do? Which means that if we're lerping here, we also want to lerp from B to A. Right? Because if this value is small, the t value is small, then we should be close to B. So we just maybe had that backwards. Let's see what that does. So create path, new path. Let's make him kind of like this and refresh. Oh, there we go, baby. Let's fucking go. Okay, so now at the very least we can claim that the mask is good, right? But he's not like rendering correctly. So I would kind of like, I think it's probably because it's make map texture from R. I think it's because we're leaving the backing store as RGB or as red only, and our texture, our fragment shader is only looking at the he's looking at a texture sample from this thing here. So I wonder if the texture sample that comes out is like 0 alpha. Right? Like that's definitely possible. So can we just, for now, just give me like, cut me some slack for a second. And if we just do this, and then we do temp R, temp R, temp R, temp R. Does that give us something that is like at least visible to us? No. But again, we refresh here and it looks correct. Okay, so that's kind of interesting for sure. I thought that would do it. So we need to look a little bit closer, I guess, at this. Text image 2D. Not sure what we're trying to do, but have you heard of GeoIntensity, GeoLuminance texture formats? No. I mean, what I'm trying to do is I'm just trying to figure out why if I put in if I feed this texture with 1 byte data, why am I not seeing it when I render that thing later? So I've just fucked something up because I'm bad at OpenGL, but I just don't know what it is. GL texture image 2D. So hello? Why can't I go? Shrimp for the win. Photoshop is a bad name. Let's go shrimp. Fuck! I just want the fucking API docs. Is there somewhere else I can get it? Here, okay. Okay, so internal format is here. Oh, it's maybe I'm supposed to type GL red instead of GLR. I'm just a dumbass. Let's try that. Because he does say it has to be GL red. Maybe I should fucking read docs. Read docs. There we go, baby. Let's fucking go. Let's fucking go. That's pretty sick. That's pretty sick, man. Okay, so we have generated a mask from the path, and now the last thing to do is to actually try to apply that thing. So if we are trying to mask something off, can we cheat for now? And maybe for now we'll say that if we apply a mask, if we generate a mask, create path, we will automatically create the masked object as well, right? So we'll just kind of do the same kind of cheat here for now, where we have like a mask ID here. And then we're gonna have to create a new object that runs a shader, which I think that we shouldn't have to like technically make any new object types here. I think we already support this, right? So I think that all we should have to do is make a new fragment shader that takes in, I guess, 2 textures, right? And we're gonna multiply. We're gonna be like sample from texture. So we'll call this like val mask. And then can we just return val times mask here? Our textures currently don't support multiple inputs, but that's probably fixable. So we have like shader object. And can we do like input images like this? Okay. And then what? Then what? Presumably this will stop building. Right, so here we have to create a new, so this should be a new masked object who is going to create a shader object is load init. Okay. So he's going to take in input images as a slice of object IDs. And he's going to, I don't know, probably duplicate these things. I don't know if that's necessary, but we're going to do this for now. Okay. Images like this. Okay. And so we are going to initialize this thing with an allocator. Object IDs, which are going to be, the first one is going to be the selected object, then to the mask then we just have the shader source, which is going to be mul fragment shader. Boom. And then on render of this thing, we're just going to have to support taking multiple textures, right? And we're going to go like 4.0 to textures len. I think you can do this. I think this works because these are like 0, 1, 2, 3, 4, 5, 6. Yeah, these are sequential. Okay. And surely this falls the fuck over. 722. So he's mad about loading from... So here we'll just write unreachable for now. I just don't want to deal with this right now. Main zig 3d8 is mad about when we initialize from images, we try to create a shader object here, and I guess we'll just do this. Okay, no, wrong one. The fuck am I looking at? Init. He does take object IDs. He does want them to be mutable, I think I saw in there somewhere. Where the fuck am I? I'm so lost. Yeah, let's do const object ID here. No field name input image, it's 72. True. Found comp time int at somewhere. Jeez. Okay, here. Lint.zig 124. True. These guys need to do a little bit of this. Stick some shit in an array. Fine. Okay, now what's this bitching about? Dupe Z is complaining probably 124. So that's in here somewhere. It must be in the shader object in it. It must be. Oh yeah, I do type dupe Z instead of dupe. That's true, little whiner. Okay, so then at 200. 200. Expected type this found that. Oh, right, because this thing is also taking in this type of shit. So in here as well, this render function needs to take in constants here so that we don't have to worry about making a mutable array. And then we should be able to do the same thing here and here. Now the problem here is that this needs to be objects, plural. So I guess we want to do like sources is going to be like a std array list of texture IDs. Or the render thing could, yeah, it's fine, it's fine, fine. It's fine. I'm not like the biggest fan of having to heap allocate here temporarily, but we'll live. So can we do like 4 s input images, input image, then we do all this, and we do sources append file system object texture like this, which means that now we have sources.items here. Nice. Okay, sources.append is mad because this thing is constant. Fine, we'll make him variable. GL texture 0 is mad because I can't add an int to a usize, so we will int cast, and we probably need to as c gl c int or something. I don't remember what it said. He wants UN. Fine. Little whiner. Okay, no field name input image on app shader object at 695. Fuck. So this is a save code, so we'll just we'll fix it later. We will fix it later. And then 368 is mad about, really? Thought it was, so neither of these work? I see. So because it's promote literal. Oh god, that's annoying. Jeez Louise. That should not look like that, but you know, we live, we learn. We'll deal with it later. All right, create path. We have a new path. We have a new mask. Masked object crashes because we don't know how to run shader on shader. Oh, sure, that's fair. So we have to create the path from this, which then will let us mask off the tree, and then the mask object says do not run how to run shader on generated mask. Okay. Which means that we fucked up when we create path. This thing is supposed to take the selected object. Do you not know how to run shader on? Oh. Do not. Okay. Do not. We need to fix that. It's correct. We just need to fix it. So on the render somewhere, we need to be able to extract the texture ID. So if we have a generated mask here, we have m.texture and f.texture, which means that this is the texture, and then this is the texture. Boom. We just need to extract the things we care about. Okay. Create path. New path. We like outline the tree a little bit. Look at the mask. The masked object is now not doing what I expect in the slightest. Hold on though. Yeah, it's not doing what I thought it would. Because I think we have to set the uniforms as well. I think that in the program, if I remember correctly, the uniform I think it's something like we have active textures. But it's not working. Hold on. Okay, so let's look at the mall fragment shader. Let's just start here by doing something else here. I just want to make sure that, like, what if we just show the original mask? New path. Okay, so we do this, and we look at the masked object. Yeah, so I think that what's happening is he's taking in two textures and then multiplying them together, but both of these textures are bound to the input active sampler zeros. Can I set the sampler 2D like this to say, like, I want you to come from input 2, so I don't have to do it somewhere else? Shader compilation failed. How do we do that? Set default sampler texture. Default values for samplers. Layout unit equals 0. Layout unit equals 0. Layout unit equals 1. Does that fix it? Create a path. Fuck! And we can't even see, like, the error. Because there's just so many leakies messages because we aren't cleaning ourselves up correctly. I know, but let me see what fucking went wrong. Layout identifier unit. Fuck. This is what I thought I was doing. This is from really old. How to set an default OpenGL texture unit. As unit location. You are right that I am using U texture twice, and maybe it's actually just right. That's a really good point. Good. I'm so glad you guys just fixed my problems for me. Okay, so this is still doing the same problem, though. Still doing the same thing where it's multiplying by the red value, right? So, not quite. Layout. What is it? We can say, like, can we just ask the idiot? I feel like he's going to be able to tell me exactly. In GLSL 330, is that what version I'm on? Yeah. How do I set the default active texture binding for a sampler? Binding equals 0. Bind the texture to a unit. Set the uniform. He's saying that you just don't do that. Fuck. Use the layout binding to specify the texture unit for the sampler. Oh wait, that is what I want. Let's see. So let's just say we use 1 twice here, just to... Fuck. Yeah, okay. So he's just like a fucking lying piece of shit. Oh, maybe I have to write core at the top? Maybe. Maybe GLSL core and non-core are different, although I don't think that's the case. Nope, okay. So he just is a lying piece of shit, as usual. Fuck. You wanted to try location? Oh, maybe they're not allowed to be the same one. That's also a very real possibility. Okay, let's do... Location's probably wrong. Yeah, I agree, but I just wanted to try it. Okay, so we're back to here. Because I'm trying to avoid having to, like, kind of custom do this for... Hold on. I was trying to avoid having to do something custom for looking up the uniform locations. I was kind of trying to avoid it, but maybe we just have to live with it. So we'll have to go into here. And can we just do like texture locations? Right? And we can go texture names here. Right? Which kind of blows, but it's fine. Then binding or whatever is might require higher version. Yeah, makes sense. We'll just do it right. So here we'll go var texture locations equals stood array list of gl int initialize our allocator. Okay. And then we'll go for texture names. Or, yeah, this should be fine. We will try to get that location. Right? And I guess this probably wants to be null terminated names, right? So that this get uniform location doesn't like fall the fuck over. Then we do texture locations, append texture location. Excuse me, sir, would you mind to take a look at how this demo website about to deliver client? Here's a website link. I'm just gonna not do that, and I'm gonna delete your message because I don't want you to like. I'm not gonna click on the link, and I don't know what's in the link unless I click it. So I don't really want like, you know, if you're just sending me like alligator dicks, I don't really want that to stay on the chat, you know. So, it's not that it's like forbidden. It's just I'm not gonna click it, and so I'll delete the message. Apologies, but get fucked. Okay, so now our texture locations here needs to be like try texture locations to owned slice. Boom, bing, bang, boom. And now everybody who creates this like plain render program needs to, oopsies, needs to pass in like the texture name. So here on like the default case, I guess we do texture names here. Texture names gets propagated. Okay. Which I feel like I got wrong here. We need a const list of these. Okay. Then somebody else calls this with u texture. Okay. So then he's pissed off because do I have to have multiple things here? I didn't think so. Vertex shader, fragment shader, texture names. Okay. Vertex shader, fragment shader, texture names. Expected 4 arguments, found 3. Am I fucking stupid? Oh yeah, I am fucking stupid. Shut the fuck up. I can read, okay? I promise. I can read. Okay, so now he's mad because Aaron is ignore it 336 or something. Try here. And then expected 4 arguments at main 388. So that's here. The swap colors was just U texture. And then there was another one, wherever the fuck we were actually trying to do, what the fuck we were doing. I don't know. We'll see. It's at appzig 174. There we go. Yep. So now it's U texture and U texture 2. Yeah. Okay, one more lint, but we don't give a fuck about lint.zig. Fine, we'll do it right. So this gets the same treatment. U texture, and then I think somewhere we have to actually use that thing, right? We have to say here that we GL uniform. How do you set this thing? GL uniform sample. Does he say how to do it in here? Uniform I. So it's going to look at self texture locations I, and we're going to set this to the value of I question mark? Maybe? One I maybe? And then incast this thing? All right. Is this the one? Come on, baby. Come the fuck on. Okay. Boom! Let's fucking go, dude! Let's go, we got there. So now we can like outline this tree or something. And this masked object now is like fucking masked off. Isn't that fucking sick? Isn't that fucking sick? Now, obviously, we've like introduced some bugs along the way, like the fact that this thing renders gray, right? That's not good. And we can't like if we generate the path like here, it crashes when we try to render it because it doesn't know how to like propagate. It doesn't know how to run like a shader program on another shader program. But we're definitely getting somewhere. Like that's a lot better than we were a few seconds ago, right? So look at that. Look at that. Let's outline the fucking tree. Boom, boom, boom. Mwah! That's so cool. Yeah, pretty stoked on that. Holy shit, it's almost 5 o'clock. I have not looked at the clock, I think, for like an hour. I guess I did to write this down, but it didn't register. So that's a 3-hour stream. No biggie. But yeah, pretty sick. So also we have to fix the like aliasing here. Like the fact that the mask is applied and like unconditionally on a 100 by 100 pixel texture is like fucking stupid. So there's like some fixes to be done there as well. But overall, pretty exciting. And I think that you can like really start to, again, like I feel like every feature we implement, like the vision of the thing becomes like a lot clearer, right? Now we can like you can kind of see, oh, we go highlight this thing and this it automatically changes. And if this thing were in the composition, which is not right now, but if it were, it would be like come for free here as well. So things are starting to come together. Pretty excited. Okay. Thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is almost 5 o'clock Pacific time now, so you should expect to see us any time between 4.5 hours ago and now if you're watching live. If you are watching on YouTube, you might say these VODs are only 2 hours to 3 hours long. Where's the other hour and a half? And I would say you have to catch that section live. We call it happy hour. We try not to do anything that is too critical for understanding and following the project, but we try to do things like handle stuff that is boring, not worth a YouTube video, etc. Right? So like today, like we will probably fix this in happy hour tomorrow. We will probably we might implement like try to do some speed ups of like the mask of the path generation stuff, right? Like we might try to like take any of those fix me's where we had like duplicated code, factor them out, right? Like kind of like minor things that have to get done but aren't worth a YouTube video. So those, you have to catch us live if you want to see those, or check out the Patreon or YouTube member sections. Otherwise, I think that's all the plugging I really want to do. If you're watching on YouTube or on Twitch, there's a YouTube link in the Twitch description. All of the VODs are archived over there if you want to check them out. They're organized by playlist. If you want to see like previous projects, we're working on this image editor now, but we've done a lot of other stuff like QR code decoder, operating system, video editor, I don't know. There's lots of stuff in there. I can't remember it all. Making a GPU from scratch type shit. So that's available if you want to check it out. GitHub link in the Twitch description if you want to see code for this, which will go up soon. Otherwise, goodbye YouTube and Twitch. Let's find someone to raid.